example on the half angle. So here I have cosine of 15 degrees, and we want to convert, like we want to find the exact value of this using the half angle. Okay, so guys, it is very specific, like we have to use the half angle. So we already have a formula for the cosine of a half angle, which is already written out here. So we're going to use that to figure out the cosine of the 15 degrees. So what the first step that we are going to do is, so the solution method is going to start by writing cosine. It's already in degrees, so remember, if you have seen my last video, it was in radians, so then we want to convert, but here it's already in degrees, so it's easier to work with degrees. Guys, first thing we want to do is we want to make this look like in a half angle. We want to convert it into a half angle, and keep in mind the theta that we want to choose should be on the unit circle. Okay, and it's like very easy to figure that out. We can use 30, and because 30 divided by 2 is 15, and 30 is also on the unit circle, so that kind of works well. So 30 over 2. Now this looks exactly like the cosine of a half angle. So where the theta is 30 degrees, right? So we can simply use the identity, right? Plus minus, this is just plus minus square root of 1 plus cosine of theta. Instead of theta I have 30 degrees divided by 2. That's all we have to do in the first step. Write it as a half angle and then use the identity. Once we have it, then we have to start, like we have to simplify the right hand side. Guys, keep in mind here, actually we don't have to write plus and minus both, because it's cosine of 15. So we already know that the for cosine of 15 is going to be positive, because actually all the trig functions are positive in the first quadrant, and 15 is between 0 and 90. It's in the first quadrant. So we're only going to get the positive value. Okay. So here, cosine of 30, then we have to go back to the unit circle and fill the value or find the value for cosine of 30. It's square root of 1 plus, and cosine of 30, if you look at the unit circle, is radical 3 over 2, and this whole thing has to be still divided by 2. Guys, this denominator is also inside the radical, so that's why I kind of I extended this, so that you don't feel like, you don't think that the radical is not with the 2, so it's also with the denominator 2 as well. Guys, let us go ahead and try to simplify. So we're first going to simplify the whole numerator. Okay, to simplify the numerator, obviously to combine these two, one has to like get a common denominator. So there's a 1 here, you multiply by 2 downstairs, upstairs. What do I get? So I'm going to write all the steps, and guys, that's what I ask all of my students, to write all the steps, and so that if you make a mistake, you can go back and look at it and you can find it and then you can fix it. So it is, now we have a common denominator, right? I'm just looking at the upstairs piece, right? So it's 2 plus radical 3 over 2, and then divided by this 2. That simplifies to 2 plus radical 3 over 2, and then I have to divide by 2 as well. But what happens to this 2? So guys, here, now still everything is inside the radical. So it is 2 plus radical 3 over 2 times, when I change this division to multiplication, I got to reciprocate this, because there's an invisible 1 here. We don't really like to write it, but we know there's an invisible 1, so it is going to be, wait, let us be careful with this. Let us see what we have. So yeah, so we have, it becomes 1 over 2, right? It becomes 1 over 2. So let us move on. Guys, this simplifies to 2 plus radical 3 times 1 is just 2 plus radical 3. But downstairs I have 2 times 2, which is 4, right? I don't want you to get confused. This is this here, and now here we are moving ahead. Okay, now let us simplify. This can be broken down as radical of the numerator, which is this, and radical of the denominator. We have been doing this in previous examples as well. Radical of the numerator, we cannot, like, if we want to leave everything in radicals, then we cannot simplify this. And radicals in the numerator are totally fine. What we don't like is the radicals in the denominator. But radical 4 is actually 2, so we don't have to worry about this. So guys, this is the value for the cosine of 15 degrees if we are actually trying to put it in radicals, and if we are using the half angle identities. Okay, so we did tangent, we did cosine. Guys, I'm not showing you anything with sine, but it's basically going to be similar to what we did with the cosine. Okay, guys, keep practicing more of these problems, and then in my next videos we're going to be working on a new section where we prove identities, where we use the identities that are already listed on our on our formula sheet and things that we have learned in algebra and other classes and bring it all together to do something more interesting and fun. Till then, guys.